So this is going to be a rough rundown of the Roadmaster referee system modules. So let's just get started, I guess. So right here, we start at the battery. This is technically not part of the module. I'm just going to turn it off for safety. Now this battery, it's just a replaceable drone battery that you can just get at DJI. Now this one is specifically a battery rack designed for robots, and you basically just slot the battery in, clicks, and to remove it, you press on the two tabs on either side, and then you take it out. To turn on the battery itself, press once, it will show you how much battery it has. Long press until it reaches all the way there, and it'll start showing which percentage of battery is it just has. And there's also a switch here, so both of them have to be activated for the power for the entire module to start working. Now you see immediately the system light starts flashing, and this gives you a seizure. And now you can see that I have all the modules on the red side. So while it does that, I'll give you a rundown of what each module is. This is the power management module. You should have seen this in the document, the rules document, and so all the others. But this should serve as a little bit of a more real-life example of what it looks like. This you can set into Chinese and English. This is the main control module. This is the RFID module. It's just a very thick card with a port behind it. Now those two, this is the tail light, and this is the armor plate. And along with this part right here, that's the armor stand. Now it secures to the armor plate via this one screw right here, and there's a latch on the bottom that allows you to just secure it without using using a single screw. All right, and now this one, this is the barrel module. Basically, detects how many projectiles and at what speed you shoot them out at. Let me get a projectile, hold on. And if I drop it through, it should add a little bit more heat. Or not, because it is way too slow, I guess. And if you stick your finger in, that's its error state. Now if it's flashing in this color, obviously you can't use it, because it's just meant to denote that it is broken. Now for main control, this is where the rest of the video is probably going to be on, I guess. So you have 4 buttons, 2 ports. Don't worry about those two. This one is for firmware downloads. This one is for I'm not terribly sure what this one is for, but we'll see. This is enter, up and down, select, and this is go back to the last one. And now we can see it is saying armor 1 offline. Now this is because we only connected that one armor module right there. This is meant to be a infantry robot, which we can change in here. And it's meant to have 4 armor. So we can see armor 1, 2, 3 are all offline. So I guess that one's ID is set to 4. And our camera is also offline. That module is over here, right? Still has the same jacks. They have 2, so you can connect them in serial. And there is also a port. I believe this one is for some sort of serial. I'm not terribly sure what this one is for. I don't think I remember. Now this is only on the robot. You have hardware on the computer to take on what is trying to transmit, which is here. And this allows the robot's camera to be camera feed to be transferred to the PC. Now back to the main module. Locator offline. They actually did translate it as locator. That's interesting. But that's basically a GPS module that's only required in RMUC, the 7 versus 7. We don't really need to deal with this just yet. And it's also a capacitor, supercapacitor module is also offline, which I didn't connect here. I have it downstairs, just didn't bother connecting it. All right, so there is a settings menu inside here. If we long press that, it'll show a few settings. Robot ID relates to which side you're on. You can set it to neutral, which sets everything yellow. I'll set it to 1, I guess. It'll reboot the robot, or it's just going to start as red. Sure. Let's try that again. Let's set it to blue this time. And now it's blue. Yep. Now just as a side note, this tail light module starts flashing yellow. This normally doesn't happen. It's just because it's in an error state. You can see why. We have not connected to the server, so it is quite confused. And we also set the robot type here. I'm going to set module IDs, speed monitor IDs, stuff like that. Also set what your HP is. That is just for debugging, I believe. You need to set up a Wi-Fi for the servers. You have debug modes that allow you to use offline mode to start controlling the robot via the remote. I have that checked. And we also have some other tests. We also have language setups and help menus. And that's about it for this module. And since we're already here, I might as well go on with some of the motors that we might see in this competition. Now, one of them, let's start with the most basic one. So this one is the default chassis brushless motor that DJI sells. This is called the M3506. No, 3508, sorry. The brushless DC motor. And I should, if I'm editing this video, I will put up a specs sheet or a screenshot of their website on the right side of the video. If I'm not, well, I forgot, and good luck. So this this motor has like 2 cables, or like, yeah, 2 sets of cables coming out. This one is for power, and now this one's for the data. Now, of course, this is 3-pin, and this is like wherever this port is. You can't exactly plug that into like the power pins on the module or like on your PCBs. And that's because you need a way to control the motor. And so we have a motor controller, the C260, also provided by DJI. Now it is missing a wire that I unplugged. Let me just find, oh yeah, no, it's not missing a wire because it is already plugged into the motor. I always forget about that part. It's fine. So I'm just gonna plug it in. And I'm not gonna run this today because I'm not ready to do that right now. So that's basically how you connect it to the motor controller. And to connect the motor controller to your or development boards, you have a, like, this is just straight up a DC port, DC XC30, and there is also either you can use, let's see here. Now the right side you can use PWM, or the left side you can use CAN. I have a CAN cable, so I guess we'll just use this for now. Let's see if we can get zoomed in. It looks like that. You kind of just plug it right in. I'm having trouble plugging in wires. This is fine. And then on your board, you'll have you'll be able to find. 1 second. I think I have my board somewhere. Yes. So here's your board. This is the Type-C board. Has STM32 on it. It's basically just a PCB, as we've discussed. Now I'm just going to take out the motor controller. Now this can either go on one of these or one of the breakout boards for power. And so it does this. There's a breakout board for CAN bus as well. You kind of just plug it into the CAN bus port, and then your motor is now connected. I'm going to disconnect that. Now this is the most basic motor. Now we have a smaller version of that motor. Let's see if I can find it. Alright, so this is the M2006. Now if you want to know how big it is, this is the size difference. Right? Like almost like, I want to say a quarter of the size, but even if that. Now it is quite similar. You can see it is still a geared down motor. The motor itself is still on the back. Now the difference is it doesn't have dedicated ports like this motor does. You can see how they made it like a unpluggable port. This one's just on the PCB soldered. Alright. Now it connects to this, this is a C610 motor controller. And let's see. It is very similar, but this time you can't use PWM anymore. You have to use CAN bus to control it because it only provides that wire. It also provides your DC power. Again, this is exactly the same as you will connect to the development board as the M3508. Now this one is the GM6020. It is a brushless motor with its motor controller already built inside the motor, so you don't have to bother with that. Now it is 3-bore. The shaft is the whole diameter is large enough to fit a bullet in. And you can also put electrical slip rings inside the hole. And that's basically allows neat wire management to allow you to keep on spinning without tangling. Now this one, it's fairly simple. You just plug in the power, you plug in one of these control methods, and you're good to go. Now there is a CAN resistor, like switch matrix here, I guess. And that's for when you want to control the device with CAN. And same with this actually. There is a configuring CAN resistor switch here, and then there's a set button. Now the difference is, to set the CAN ID for this, the way that you do it is, I believe you long press it and then you press once, twice, 3 times, 4 times, all the way until 8 times to set its this controller's ID. And you do it for each controller. But for this, you can just flip the switch in different order and it will just set it. Now, I have another one. This one I don't have it on by itself. I have the entire mechanism. Now, what I'm talking about is this motor here. This is the Snail 2305 motor. It's meant to be on drones, like higher power drones, stuff like that. Spins very quickly. Most teams use it to launch the 17mm fluorescent bullets, projectiles, whatever you want to call them. But it does lack a little bit of power, even for that. So we're not going to touch on too much about it. all you need to know is it doesn't really provide a speed output, or like doesn't provide backwards input is what I meant. Like it doesn't like give you an encoder input. Now it is controlled purely through PWM, and you connect it through power. Now I guess I should probably touch on PWM since we might need that. So let me take out the board again. So for PWM, we have a lot of 3-pin ports here. D bus is reserved for the controller, so don't worry about that port specifically, but all those ports we should be able to use. For PWM, you see the side with the notch, and you can also see there are notch holes or slots that allow you to kind of just slot it in. Now, if there aren't, I guess just remember the ground is on the right side. As you can see, if I slide it in, it's going to be on the right side. So I think that should be it for all the absolutely basic hardware that you need. I guess we can include one final thing. This. So this is the breakout board that I was talking about. You can see it has quite a few CAN bus ports, as well as if you need it, there is a XT60 port right there. Now the way that you connect it to a motor is the same as the development board, but the way that you connect those to the development board is also the same. So it is kind of like you just connect them together and it works. Pretty neat little thing. We'll probably get more of those. And yeah, that should be all. Let me know if you have any questions, and we'll start actually doing something finally.